some of the previous ones. So when we talked about shape area, just as a bit of a review here, we started with something that actually created these things, these shapes, and we did that using a matrix. So we've actually caught a bit of a glimpse of matrices. If you want to review, you can take a look at the shape area video, but the main thing is that wasn't something we had to do for this algorithm, but something we did do. So we used a matrix. It was basically an array full of other arrays, and then we did a nested for loop to traverse that matrix. So today we're going to be officially using a matrix, as you may have guessed from the title here, matrixElementsSum. So we're talking about a situation where there's legitimately a matrix here. We will have to use a matrix. And that's pretty exciting, and it's nice that we sort of have a little bit of background information already, but we'll probably cover a lot of the same stuff today. So before we get ahead of ourselves, let's just see what the question's asking.
After becoming famous, CodeBots decided to move to a new building and live together. The building is represented by a rectangular matrix of rooms, each cell containing an integer, the price of the room. Some rooms are free, their cost is 0, but that's probably because they are haunted, so all the bots are afraid of them. That is why any room that is free, or is located anywhere below a free room in the same column, is not considered suitable for the bots. Help the bots calculate the total price of all the rooms that are suitable for them.
Okay, great. So just to review, I mean, we sort of got a taste of this one of the previous times, but the code bots, we're talking about these guys. So we've seen Radiorg before. This time we're talking Integris, Pillin, Alpha. The whole gang's going to be there. Okay, so all these guys, they've become famous. I mean, look at how many wins they all have. Anyway, the point is they're moving in together. And this matrix here sort of represents the rooms. It represents the rooms that they could possibly be moving into, but some of the rooms are free, and those are the ones that are, well, it says probably because they're haunted. The point is, I guess the code bots are very superstitious. They don't want to move into a room with a 0, but they also don't want to move into any room below a 0. And something that we should be clear about here is it's not really clear from this example, so I'm going to look at test 2. Yeah, in fact, just to make this line up a little better, let me just copy this over here. Perfect. Okay, so in test 2, something to note is that over here, we've got a 0 in, it's a little thick here. We've got a 0 right there. So that means we don't want to consider the 1 below it, but also we don't want to consider the 10 below that. Basically anything that's at all below a 0, we want to just throw it out. We don't want to consider it. So that's not necessarily clear from the description or the example here, but that is the way we're supposed to interpret this problem. Okay, so that's an example. Now, how are we going to do this? What's our game plan here? Well, first of all, let me just sort of clear this for a sec. Now let's talk about what steps we could be taking here. So in terms of how we'd interpret this, well, one way we could do it is we could sort of keep a list of columns that we're not going to use. So we'll go through the array one element at a time, and we'll just start here, go to the next, go to the next, go to the next, then hop on the next row. And basically, as soon as we encounter a 0 in a particular column, then we'll say that column is basically dead to us. We're not interested in looking at that column anymore. So basically, it'll go to this one, go to this one, go to this one, and then the next time it gets to that column, it'll say, no, there was a 0 there before. We're not going to use that column. And it's just going to ignore it from then on. So we could use a strategy like that. And then basically, it just becomes a matter of checking as we're going through the matrix. We can say, well, has this column had a 0 in it before? Oh, it hasn't? Oh, okay. Well, in that case, is this a 0? And if it is, we'll add it to our dead columns list. If it isn't, we'll add it to the total, because that's ultimately what we're looking for here. We're looking for the total of all the numbers inside the rooms that are not haunted or below a haunted one. That's basically it. So we're going to have a total. Might as well just say let total be assigned the value of 0, and then at the end we're going to say return total. That's basically, our main game plan, that we're going to count all these and then return them at the end. And notice I'm using this let syntax over here. We're just going to sort of get in the habit of that. It's just usually a better syntax to use than var, but it means mainly the same thing. The difference is that it's block scoped. Okay, so then from here we're going to loop through the matrix. We're going to say if we encounter a 0, add that column to a dead list, and then if it's not a 0 and not on the dead list, then add to total. And that's basically it. I mean, that's the main thing we want to be doing here. Okay, so make a little bit of space, and then we'll actually go through these. So in terms of looping through the matrix, well, we're going to do nested for loops like what we saw before. So actually, let's get in the habit of using let. So let I be assigned the value 0. I is less than matrix.length and I plus plus. Okay, so from there, I just want to do a quick console log of matrix at I. So we can see, what's actually in this matrix. A matrix is, after all, just an array. It's an array that contains other arrays. So this whole thing here is the matrix. In terms of the elements of this matrix, well, the first element is this array, the second element is this array, and the third element should be this array. So when I run this, first of all, I'm probably going to get a 0 because we're not actually changing the total at all. And in terms of our console log, yeah, there we go. So it's the 3 rows that we were looking for. Okay, so that means if we want to talk about a particular element within a matrix, like for example, let's say we wanted just this column 1, let's say, column 0, column 1, column 2, column 3. So we'll say we want column 1, we want the elements of column 1. So basically, instead of matrix at I, because each of these things is a matrix at I, this is matrix at 0, this is matrix at 1, this is matrix at 2. So let's say we want matrix at I at 1. So we want to get the index 1 element from each row of this matrix. So what we should expect in the console log is just a 1, a 5, and a 0 at this point. So we'll run it, and there we go, 1, 5, 0. So this is sort of the syntax that we're going to use when we want to talk about a matrix. You can sort of think about it like the coordinates of an ordered pair, Cartesian plane style, but a little bit different because we need 2 sets of square brackets there. The other thing is we don't just want index 1 in terms of our column. We want to go through all of the columns. So that's why we're going to use another for loop here. So we're going to say for let j be assigned the value 0. J is less than matrix.length, j plus plus. And then from there, we'll do console.log matrix at I at j. And we'll see what we get from that. And when we run that, we find we get 0, 1, 1. Okay, so far so good. But then 0. 0, 5, 0, 2, 0, 3. We're missing some elements. We're only getting 9 out of the 12 elements here. And you'll notice it's 0, 1, 1, 0, 5, 0, 2, 0, 3. Okay, the issue here is we're saying matrix.length here, and we're saying matrix.length here. If we think about matrix, matrix is an array that contains 3 arrays. So more generally than that, it's an array that contains 3 elements. That means matrix.length is 3. So j is only going up to 3. Or technically not including 0, 1, and 2 is what it's covering. 0, 1, and 2, 0, 1, and 2. We don't want it to be matrix.length. We want it to be the length of the thing that's inside matrix. So we could say something like, matrix at I.length and see how that goes. Okay, so now we're getting all the elements? Yes, we are. 0, 1, 1, 2, 0, 5, 0, 0, 2, 0, 3, 3. Okay, so that's giving us all the elements we're looking for. But if you think about it, matrix at I.length. So basically, as it goes through the loop, so first I is 0, so it'll do matrix at 0.length, so it'll find that that's 4. And then when I is 1, it'll say matrix at I.length, and it'll find that that's 4. And then it'll do matrix at 2.length, which is 4. So if you're noticing a pattern here, they're all the same. And we can tell that because it says within the description, it's a rectangular matrix. So it's not that it's going to have a ragged edge or anything like that. All of these arrays within the matrix are all going to be the same length. So we could get away with just doing this, matrix at 0 dot length. It doesn't have to be I. And in fact, maybe it's better to use 0 because we know no matter what, there's always going to be a 0th row. There might not be like a second, third, or fourth, but there's always going to be a 0th one. In fact, if we check the constraints, we can see that reinforced here. We see that it has to be at least 1. So there's always going to be a 0th row, so we can always use that. The problem is this is still recalculating this every time we go through it. So basically, this is calculating matrix at 0 dot length 3 times. That's not too significant. It's not something we should necessarily worry about, but I mean, in general, you kind of want to have an allergy to repeating yourself and repeating calculations when you're programming. So since we don't want to repeat the calculation, we'll just say something like let rows, or we could say, number of rows or something like that. But I think this is descriptive enough, so we're going to say let rows be assigned the value of matrix.length, and let calls be assigned the value of matrix at 0.length. And then in this case, we can replace these with rows and calls. And that way we're not recalculating. We've stored the value in a variable, and we can reference that value without having to recalculate it. You'll notice it's still going through all of our elements here. Okay, great. So what do we actually want to be doing inside this loop? Well, basically this. Okay, so if we encounter a 0, add that column to a dead list. All right, so before we even get into that, let's just say let element be assigned the value of matrix at I at j, the thing that we were console logging just a minute ago. And then also we kind of want to have this dead list going, so I'll say dead calls is assigned the value of this empty array. And if we encounter a 0, add that column to the dead list. Okay, so we can do that. So we'll say if element equals 0, then we'll add it to the dead list. So we'll say dead calls dot push, and then what's the name of our column here? Well, it's j. J is the thing that represents the column we're working in, right? So we'll say push that column into dead calls if we have a 0. If it's not a 0, then we should probably check if it's in there already. So we'll say if dead calls dot includes j, and if it does include j, we basically want to do nothing. We want to just move on to the next one. So technically what we're really checking for is if it doesn't include j, if it's not a dead column. Okay, so if it's not a dead column, then basically we're just going to say total plus equals element. We're going to add the value of our element to the total. And I think that's what this column comment is saying. So here we go. If it's not 0 and not on the dead list, then add to the total. Okay, so not 0. Well, it's a guarantee that it's not 0 because of this here. If it makes it to the else, then obviously it's not 0. And then this is checking if it's on the dead list. And if it's not, it's adding that right to the total. And again, since this is just a single line, we could just move it over here. I mean, that's a stylistic difference more than anything else, but I'm going to choose to do it just because, that's not very long. It's nice, it's easy to look at, it flows. But that's a personal preference thing, so if you don't want to do it that way, that's fine. It's up to you. Okay, so this is basically our algorithm here. So let's see, are we missing anything? Let's give it a try. Run the tests. Wow. Okay, that's got to be a record. I mean, we're not even 20 minutes in yet, and we've already got a working solution here. I mean, I haven't tested it for the hidden tests yet, but I'm pretty confident. I mean, I don't think there's anything too wacky here that they could throw at us. So, yeah, I'm pretty confident that this is going to work. In fact, hey, we might as well, right? We might as well just try submitting it, see if it has an error. No errors. It worked. And in fact, it's kind of a special thing because we have completed the Edge of the Ocean. Look at that, the 4,000 coins. Oh, that's nice. That's definitely a nice little reward. But I'm not satisfied with this. I think this could be better. So part of the issue I have with it is this right here. So we're going to do a console.log and we're going to see, well, what does dead calls look like at the end of this anyway? Like after this is all executed, what do we have in there? And so we're going to get a look. I mean, obviously it's still passing the test. Okay, so in this case we've got 302. That's kind of interesting because they're not in order here. So if we look at this, the first 0 we're going to encounter, there it is. So it's basically saying column 3, you're dead to me. And then the next one, the next row, we say, oh, column 0, you're dead to me. And this one's fine, but then column 2, you're dead to me. And it continues and doesn't find any more zeros after that. So it's basically just 3, 0, and 2. All right, so that's good. I mean, that works. Nothing wrong with that. But there's kind of an issue with this one. If we take a look at this, we've got 0 more than once here, and that's kind of strange. So it's basically, it's pushing the 0 there, and then it gets to the next line, and it's pushing the 0 again because it encountered another 0 within that same column. So that's kind of not exactly what we want. We don't want to have repetition in our dead calls here. That's not something we're really interested in. Now, there's a way we could fix that just by sort of restructuring our conditionals here and switching around the order of our ifs. But I specifically want to use this as, I guess, a bit of a teachable moment because there's this new syntax that we can use for exactly these kinds of situations. So if you're familiar with math, if you've heard of math before, there's this thing in math called set theory, and basically the idea is that we're looking at sets of things. So a set of things it's very much like an array, except we don't repeat elements. So like for example, in this one, we wouldn't say that this is 0, 0, 2, 3, 1. We would say it's 0, 2, 3, 1, or even 0, 1, 2, 3. It doesn't matter. Order doesn't matter. Repetition doesn't matter. So that's the mathematical notion of a set. The nice thing is that within this new JavaScript syntax, within this new ES6, we actually have set. We can use a set instead of an array. So that's really cool. And we basically instantiate it like an object. And so we saw that before when we were doing new arrays, when we were doing array.fill, that kind of stuff. But basically, we can see some of the properties in here. It has .length, just like an array. We can do stuff like we can add. So instead of push, we'll just add it. Or actually, instead of push or instead of, what's the other one, unshift. The main thing is it doesn't matter whether we're adding it to the end or the beginning. It's just in the set. Order doesn't matter. Clear, we can get rid of all the elements. We can delete a single value. I mean, there's lots of stuff that we can do with a set. We're not going to use too much of this. We're basically just going to check if it contains the value. So we're going to use has instead of includes like we've been using. And then we're going to use add just to put it in the set. So these are the these are the docs here. If you actually want to read more about this stuff, this is set. It's just a Mozilla web docs, so you can check that out. But as for what we're going to do over here, we're going to say dead calls. It's not going to be an array. We're going to say it's a new set. Okay, it's a new set, and this is basically for our constructor. Like we could put some stuff in here. We could say it contains 2 and 5, for example, and then it would just instantiate itself as a set with the elements 2 and 5 within it. But we want it to be an empty set, so we can just do this, and that should be fine. Okay, and then instead of .push, like we said, we're going to add it to the set, and instead of .includes, we have this really nice syntax, has. Okay, so this, I think, should work the same way. Let's take a look. Or maybe not exactly the same because it's a set object now, but if we look at it, great. The set contains 0, 2, 3, and 1. It's not repeating the 0, and also it's still passing all the tests. So I consider this a little bit better than what we had before. We've got this new set notation. And I mean, like I said, this isn't the only way we could have fixed the issue here. We could have changed this around and we could have reordered this a little bit just to make it a bit smarter, but I just wanted to use this as an opportunity to go over this set business. So if ever you find you're in a situation where you want to use an array where we're not like counting elements more than one time, where we're not like recounting elements, use set. You might as well. I mean, technically, I guess we could use it anytime we're looking at an array, but might be overkill. I'm not sure. Anyway, the point is that's a tool you can use. Use it if you want to use it. Okay, so I want to use a bit of a different strategy here. So like we've done in the past, we're going to comment this one out, and we're going to try something different. But I think we're probably going to use mainly the same kind of approach as what we did down here. So I'm actually just going to copy this. I wanted to archive it, so we've got that commented out version. But there we go. Okay, so now we've got same algorithm. I want to rework it though, because if you think about it, the way we're going through this matrix here is we're going from left to right. And so we're kind of doing like, we're going through these elements here, and then we're going through these elements here, and then we're going through these elements over here. But if you think about it, that's kind of more work than we need to be doing here, because if we already know that this column is going to be excluded, if we already know we're not going to consider anything in this column as soon as we see the 0 here, then why bother checking this and why bother checking this? We might as well just skip them. So here's a new way we can conceptualize our algorithm. We can say, let's start with the columns. Let's actually go down this way and prioritize going from up to down and then from left to right. And then basically the idea is that at that point, as soon as we find a 0, we can just break out of that loop. So we would basically say, oh, that's a 0, stop there. And then, oh, that's a 0, stop there. That's a 0, stop there. That's a 0, stop there. So we really don't need to consider nearly as many elements as we did before. This is going to be a lot more efficient than our previous interpretation. Okay, so I'm going to close this, and then the first thing I'm going to do is basically I'm just going to switch these. I'm going to switch the order of the loop. So I'm going to say we're going to prioritize the columns now, and then within each column we're going to look at each of the rows. So we'll start on the 0th column, row 0, row 1, row 2, then the first column, row 0, row 1, row 2, etc. Okay, so all right, that just switched the order. I mean, does it still work the way we have it? Yeah, it still works, but you know what? Maybe it's overkill, because basically the idea now is we don't need to really consider this dead list. No dead list business to even have to think about, because basically what we find is that if the element is 0, we're going to break out of the loop. We're just going to say break. There's no sense in checking the rest of the rows within this column because there's already a 0 here. And if it's not 0, then well, we don't need this if anymore. We can just say total plus equals the element. And I propose we even delete dead calls here because I don't think we need it. So let's try this. Let's see if it still runs. And it does. We didn't need that extra array here, taking out memory. We can just, actually we can make this even a little shorter. Like I said, these are one-liners, so we could make it just like that. That's kind of not bad. I mean, there's fewer lines than what we had before. And if you think about it, it's, here, I'll just make a comment here. Go to next call if you find a 0. There we go. So, that's pretty nice. Not bad, right? So, okay. Oh, hey, ATD. That's super great to hear, my man. And yeah, I really agree with you. You really feel like you accomplished something when you crush one of these challenges. Okay, so let's move on from here. I mean, this algorithm, it's better than what we had before, I think. Hopefully we can agree on that, but I don't know, maybe there's another way we could look at it still. So this is running though. Let's just verify that's passing all the hidden tests. Yeah, this is fine. In fact, you know what? It's probably better than what we had before because in terms of computation time, like it's stopping as soon as it needs to. It's not holding an extra array in memory with this dead calls thing, and it's not going through the loops as much, you know, like it's breaking out of the loop as soon as it can. So this is definitely going to be a faster algorithm. It's going to have better computation time, better memory optimization. Hey, Will, how's it going, man? All right, we're going to try another method though, because there's something we can do here. So check this out. this is more of a novelty solution than anything else. I don't know if this is actually going to be better than the previous one, but we're going to try something different here, and at the very least, it'll be kind of amusing. At best, it'll be a tool that you might use in the future, but I'm not going to guarantee that this one's actually going to be a better algorithm than what we've been looking at so far. So let's see. Maybe we can get kind of a pale seafoam color. That'd be nice, right? All right, so let's try this. I'm just going to reduce the thickness a little bit. And what we're going to aim to do here is use a single for loop. We've got these nested for loops, and we found that like in task 7, using nested for loops kind of gave us a bit of an issue because it made our computation time too complex. It basically gave us big O of n squared. It gave us a quadratic time complexity, and that was enough to time out the task. I don't think we're going to have to worry about that in this case because we found like, these are really small constraints. Like it's only going from 1 to 5 in terms of the length of both the rows and the columns. So we're not going to have to worry about this being huge, but maybe if we can avoid a nested for loop, maybe that'd be better. So we're going to use a single for loop, and we're going to use a new iterator. I guess we'll call it k. Right? So k, and I want to do a bit of a table here to see how we're going to get I and j out of this k value. All right, so basically k, first of all, it's going to go through every element here. Or maybe this way, we'll see. But the point is k is going to start at 0, and it's going to go all the way up to and not including 12 in this case, because there are 12 elements. So basically k will include 0, it will not include 12. Okay, great. So k is going to iterate. It's going to be 0, it's going to be 1, it's going to be 2, 3, 4, 5, 6. Maybe that's enough for now. Okay, so then from here, what are we going to do with this? How are we actually going to get I? How are we going to get j? So basically, I is going to be, which one was I? I was our rows. So since I is going to be the rows here, we're going to say I is assigned the value of, and then we're going to do a calculation on this thing. So we'll say it's going to be assigned the value of k k mod 3. That's my claim here. Okay, so basically I is going to be k mod 3. And then j is going to be the floor of k divided by 3. Okay, so where did I pull these out of? Maybe it's not too clear right now, but let's take a look at the table here and let's try to calculate these things and see what we come up with. Now, just as a reminder, the modulus operator is going to give us the remainder when we divide by this number. So k divided by 3, what's the remainder? All right, so we'll start with 0. So 0 divided by 3, remainder is 0, and the result is also 0. Divided lengths of value by length of array in main array. Yes, yeah, exactly. The 3 is basically the number of rows here. Okay, so then k is 1. We'll say 1 divided by 3, that has a remainder of 1. And the quotient would be a third, but that'll be rounded down to 0. Then for 2, we divide by 3, the remainder is 2, and it would be 2/3, which also rounds down to 0. And then once we get to 3, we're saying, well, 3 divided by 3 has a remainder of 0, and it has a quotient of 1. 4 divided by 3 has a remainder of 1, quotient of 1, or at least when it's floored. 5 divided by 3, remainder of 2, quotient of 1. 6 divided by 3, remainder of 0, quotient of 2. Okay, so now if we take a look at this, this is actually working just the way we had it before, because we had our loop over here. So this one was our j loop. J went from 0 to 4. And then within that, we had this other loop which iterated I. So I goes from 0 to 3 in this case. Or, well, yeah, not including 3. Anyway, the point is, that's exactly what's happening. Our j value is just 0, 0, 0, 1, 1, 1, 2, 2, 2, etc. Whereas our I value is going 0, 1, 2, 0, 1, 2, 0, 1, 2. So basically, it's saying, let's do this one, then let's do this one, then let's do this one. Then we'll move on to this one over here, then this one over here, then this one over here, etc. So basically that's the way we're going to do this. We're going to say that now we're just going to use one loop. It's going to have a single iterator. It's going to be k. And then after that, we're going to calculate I and j from there. We're going to figure out what I and j would have to be. So let's clean this up a little bit. So let k be assigned the value 0. K is less than equals k plus plus. But there's a bit of an issue with this, and it's the fact that remember k was going all the way up to 12, not just 4. So it actually has to be the whole number of elements here. There are 12 elements. How could we calculate that? Well, it's a rectangle, so we can use our area formula. Rows multiplied by cols. So that'll give us our 12 or whatever it happens to be for the given matrix. Okay, so let's see. Is the biggest draw of learning algorithms for technical interviews. I think it's also diagnosed problems with other websites too. Well, ATD, I mean, I'm primarily a web developer kind of guy. I like to do websites, web apps, stuff like that. So for me, algorithm design is super important because computation time is basically going to determine how fast your page loads. And look, that could be the difference between someone sticking around or someone making the decision that it took too damn long and they're going to go with your competitor or something like that. So to me, that's the main reason. But look, I mean, regardless of what the application is for what you're programming, you want it to go fast, right? You're never going to have a situation where someone's going to be like, I think that algorithm went a bit too fast. Could you make it slower, please? So that's what I'd say. Anyway, okay, so going back to this here, we've got, well, actually, we can't get that element yet because we don't know I and j. I think what we said is that I was going to be equal to k mod rows, right? It was 3 before, that was the number of rows. And j was going to be the floor of k divided by rows. Okay, so now we have I and j again, and that way we can get our element. And let's see, is this still going to work the way it did before? No, it's not working. So why is it not working? We're actually getting a 0 in this case. Well, that's no good. It's because of this. This is the issue now. So we're saying break. That's the problem, because now there's only one loop here. So before, when we had our nested loops, as soon as we did this break, the break applies to this loop, the sort of inner nested loop. It's still going to move on to the next iteration of the outer loop. Whereas now we have just this one loop. So if it breaks that one loop, it's done. It's not going to continue. It's not going to go any further than that. Okay, so then instead of break, we're basically going to move k up to the next row. So we're going to say, oh, well, if we get a 0 here, skip this one, move on to this one. So basically, we're going to say, we're going to reassign k. We're going to say k plus equals rows minus I. Why rows minus I? Well, we're saying k, whatever it is. So in this case, it's equal to 0. And then we want to add rows minus I. The reason is because we want to add whatever we haven't gone through in this column. Basically, if we're at this one, we're checking that, we've got a 0. We want to add all 3 of these and make it to 3 as our next number. But the thing is, we already have a k++ over here, so we're automatically going to be adding 1 to k. So because of that, we actually want to subtract 1 here just to make it the right number after it adds the 1 up there. So let's run that, and beauty. It's working just the way we want it to. Go to next call if you find a 0. Yeah, that's pretty much what we're doing here still. Now there's one last note here I want to just go over, and it's this. So basically, I'm going to flip these around. I'm going to say, you know, focus on the positives here. So if element is not 0, then it's going to do this stuff, and if it is 0, then it'll do that. So this should work exactly the same way. And so you might wonder, well, why'd you bother doing that? You know, any sense in real flipping him around like that? Well, number one, I guess I want to sort of focus on the positive element of what we're doing here. This is our ultimate goal. We want to be adding on to the total. So just semantically, I guess it makes more sense to put that first, and then this is what's going to happen if we don't get that. But then the other reason I want to put it in here is because if element is 0, that's going to get typecast to false anyway. And if element is not 0, then that's going to get typecast to true. If it's any non-zero number, then basically it's going to say, like for example, if 5, then yeah, that's true. Move on to total plus equals element. So I don't need that part. I can just say if element. And that's kind of like saying if element is not 0. It's the same sort of thing. So that's kind of like that, if this is true, return true that we looked at last time. It's just we don't need to include it. Now the thing is, I don't know if that makes it more clear to the reader or less clear to the reader. Probably less clear, to be honest, because if they don't know about that whole typecasting thing, then it wouldn't be clear to them. And in fact, that typecasting works differently in other languages. Like, for example, I believe in Ruby, a 0 would be still typecast to true. Like any number, even 0, would be considered true. So we would have to specifically say if element is not equal to 0. So it's probably better to put that in there, but don't need to. Okay, so I think this is probably, well, it's done. We could submit this, and I don't think it's going to be a problem. I think it's going to pass all the tests just like it did before. There we go. Yeah, okay. So that's nice. We got to see the correct screen 3 times this time. That's exciting. But anyway, is this the best algorithm? I would actually say no. I would say that this one is probably the best. Probably the best algo. Okay, let's put that in there. Why do I consider this one the best? Okay, well, good question. Let's just clear up a bit of the space here and in here. So, well, this one just has 1 loop, and this one has 2 loops. So you could say, well, isn't it better to have a single loop than 2 loops? Well, not necessarily. I mean, the reason it's normally a problem when you have nested loops is because you're basically squaring the complexity here. You're basically saying, well, I want to run through this loop, and for every iteration of that loop, I want to run through this loop a number of times as well. So you're kind of like multiplying the 2. Thing is, we're already multiplying rows by calls here. This is exactly the same number of calculations as we're going to have here. I mean, we're breaking out of the loop as soon as it discovers a 0. So I would not say that this is more efficient than the other one. It's the same number of calculations. But actually, it's more calculations because we have k, and then from there, we're calculating I and j. We need to recalculate them every single time, as opposed to down here where we have I and j in memory already, and we're just iterating them as we need to. So I would say that this is the better algorithm. I mean, it also, I think, it's slightly more terse, not as many lines. So it's the best algorithm. Now the other thing is, I mean, we're holding just slightly more in memory here because we have not just I and j, we also have k. But again, I don't think that's going to be too significant. Anyway, at this point we've got our best algo. We've got, like I said, kind of a novelty algorithm here as well. The reason I say that this is not the best is because, well, like I said, it's time complexity is about the same. Memory is a bit worse. Human readability, yeah, I'd say worse too, because I mean this one, you have a loop for the rows, you have a loop for the columns. It's pretty clear. In this one, what's that loop doing? I mean, could we easily explain that to someone? You would have to know about these operators as well. So we're sort of bringing in more stuff that the reader would have to know about in order to get this algorithm. So okay, I think we're probably good for this one. If anyone has any questions, let me know. But I think for now, let's get out of here and we'll see what's next.